All right, so this is going to be a little bit interesting. It's not 3D printing. This is actually going to be CNC, sort of removing material. This is my logo, and I went ahead and just threw it in here with an SVG and converted it to some Gcode that will be used to move the spindle around. And with that, I'll go ahead and pull up my Simplify 3D and then my machine control, and then I can open up the Gcode and run it through this. But I'm sure you're curious what the heck is going on here. So let's just real quick take a look. So basically I've taken a Dremel and I 3D printed out of nylon a clamp that goes from the ender to print head and clamps around the CNC flexible deal. You can see the Dremel motor is there, and it spins this tiny little, I think it's like 3.2 single flute end mill. And yeah, it's been a little bit of trouble getting all of the software, the Marlin configuration set up, because that's all kind of meant for 3D printing. So I guess the long story on this is a friend's Ender 2, and the heated bed stopped working, and so he couldn't really use it because it would just like max temp error out, and he couldn't figure out how to fix it. So he was like, here, you can try this out. I'm not using it. So I've been fiddling with this, and I think I've got everything working. I've even got the Z probe touch plate and all that stuff working, which is pretty wild. So, all right, we're just gonna run through this real quick, and I wanted to show you how this all works. So I'm gonna go ahead and connect this guy so that we can find our Z and stop plate, and it'll make that electrical connection and know where the material on the bed is. So I'm gonna have to go run the code over here. We're just gonna open up that file. I guess real quick, for those of you that are interested. So basically everything right here was just kind of kicked out for the path, but everything above was some custom Gcode to kind of get it all set up for what I wanted, the beginning and ending. Basically it homes all axes, resets extrusion distance. That's just to make sure it doesn't have a long extrusion error, and then stop the print. And then we've got this right here is the kind of the special sauce. It took me a little while to figure it out. It's super simple, but I rewired the micro switch for the Z and stop, and I now have it set up so whenever there is a connection, it zeros at that level. But then I measured the plate to be 1.5 millimeters thick, so that here when it does, it zeros all axes and then subtracts 1.5 off that to set the true zero at the bottom of the material. Anyways, all right, enough of that. I'm sure y'all all don't care. Anyways, so let's start making chips. Let's go over here. Let's, where is this? All files, NV logo. So when I click this, it'll start going. So, all right. Oh dear. Well, I'm gonna hold this down so it hits the plate. This is not as ideal, trying to hold a camera. Sorry, there you go. So it just touched off the plate and stored that Z height as 0. So now I can remove all of this. There we go. All right. Okay. I'm gonna try to put this on a tripod now. I'm sure you're getting a little seasick. All right, here we go. Let's put this on a tripod. Okay, so at this point, I have the code set up so that it's waiting on me to remove the Z plate, all the clip and everything, turn on the Dremel, and then I'm going to click the button and it's going to start going through the rest of the code. So I'm going to do that. It might get a little loud, but here we go. So now it's going back down, and then it should move across and start cutting. It's kind of loud, sorry. should get more interesting here in a second. There we go. Alright, so the end is done. Just going back to finish that up a little bit. We'll wait for the B to get cut out, and then we'll go ahead and stop it, and I'll show you some more about the mounts. I think it's going for a second pass, so it dropped Z height and it's cutting it out even more, the deeper pocket. We're almost done. Hold on, guys. It's just crazy to me that you can get an Ender 2 set up to do some CNC cutting. It's pretty wild. I know this is loud. Give me a second. After we get through this end, I'll go ahead and kill it. Oh, the material that I'm milling, good question. It's just like this foam board. It's really super, super soft. This is just, like I said, I haven't really cut anything with it. This is still like I'm testing it out to make sure everything works. I've got some other materials that I want to play with later, once I've kind of proven that everything works. But this is more or less just like a proof of concept still. Like just 20 minutes ago, I got this together and was like, oh my gosh, I gotta show everybody. So yeah, this is just cutting foam board, super soft, not really that big of a deal, but it's just showing, you know, proof of concept that it can do it. It can run the Gcode, it can do everything. And there is the bottom of the B. We'll do the top of the B, and then I'll go ahead and kill the, it's not a print, the job, I guess. And then we can talk a little bit more without having that really bad noise. I really need to get a vacuum boot or something on it too. Even with just the foam board, it's kicking stuff up everywhere, but okay. I think I'm gonna go ahead and kill it. Let's see here. I'm gonna try to stop it from Simplify 3D. It'll take a second. Once the gantry stops moving, I'll go ahead and kill the router. Okay, that's it. Oh my gosh, that's loud. Apologies. It's kind of one of those things though. All right, so I'm gonna go ahead and get this gantry up. Oh, it's still holding the motors. I gotta disable the motors, disable. All right, all right, all right. Oh, wrong way. Here we go, here we go, here we go, here we go. And yeah, I have it in a cardboard box because I just don't want all this like debris going over. I don't have a vacuum boot or whatever set up for it just yet. All right, so let's take this off real quick. So yeah, I mean, it obviously looks a little bit rough because it was kind of tearing the paper, but as far as like cutting the foam, you can see that it was doing a pretty good job cutting the foam. Now I really don't know how well this will translate to any other materials, but it's definitely working. Okay, so like I was saying, that's just a test. Now I have some other materials. This is G10. So it's a, not carbon fiber, it has like a glass fiber in it, and it's actually pretty daggum stiff. This is 1 millimeter, and this is 2 millimeter. So this is ultimately what I would like to try to cut. I don't know how it's gonna go. We're gonna definitely test that later, after I get all this stuff, you know, squared away and working for sure. Ultimately, I wanna be able to cut smaller micro quad frames out of some G10 and do a combination of like 3D printing and some CNC milling for G10. So I don't know, that's what that is. I guess questions as far as how in the world are we mounting this? I'll kind of show you a little bit more. There's 2 clamps here. Here, let's shift this whole guy like this. Basically here, I've got actually another print. So this is a piece that I modeled up, and this basically fits, and this honestly, it fits perfectly on the CR10 as well. It has the exact same mounting plate for the print head as the ender, which is kind of cool. So I was able to use the work that I had done previously for this guy and the back of it, getting everything measured out. But anyways, this plate goes on to the back, and then all the hardware holds that to the plate really rigidly. And then we've got a second plate that you put it's basically just a pin for the Dremel, and it has like a flex line so that you can hold just the Dremel tip and cut and be more mobile, I guess, without the weight of the motor. But anyways, I've just mounted that on there and then clamped that on top. And this is printed out of nylon, and then I used, let's see if I can show you the back side. Well, I used those brass nuts that you can like heat up and like melt into the 3D print, so it gives it really good like threads. I used that on the back side, the 1, 2, 3, 4, 5, those 6 holes, so that when that goes on, it holds it really tightly. Anyways, yeah, so some real quick things that I ran into while trying to get all this to work. First off, like I said earlier, the max bed temperature was just a weird error, so I had to go back through Marlin. I had to flash the bootloader on this so that I could modify the Marlin firmware to then upload. So you have to put the bootloader on it, then you have to modify Marlin firmware and then upload the firmware to this. But basically I just turned off, and if you look, let's see here if you can see this. If you look on the screen, the display, you can see that there is just a hot end and there's no heater bed. And you also notice the hot end says -14 degrees. So I turned off the hot end. I just disabled that in the Marlin firmware. So whatever error was fighting us earlier, we were able to get past that. And then for the extruder, I went ahead, since we have no hot end, no extruder, even the stepper motor up here for feeding the filament has been taken off. It's basically stripped down to just the gantry, moving the plate and then the arm. There's no other electronics for 3D printing or feeding filament in or heating any of that up. I've stripped it all down, and we're just holding this Dremel tool pin, and we're moving that around. Anyway, so once we get past all the heater issues, because there's a min temp that if you try to move or travel or do anything or do a print, that the printer says no, you haven't heated up the hot end or the heated bed enough to be able to print, and so it tries to like save you from having problems with that. But in this situation, we got rid of all that. And then I guess the next biggest hurdle was this is just tied to the Z-stop. So like this, let's see, yeah, you can see it. This micro switch right there, it's still there, but I'm not using it. I unplugged it from the board, and then in its place, I plugged in a cable that's just literally 2 open ends. And then the way that micro switch works though, is that it's normally closed. So it would be like this, and then when this comes down and hits it, it opens up the switch. So whenever the controller sees that the switch is open, it knows that it's hit the micro switch. So I had to go in there, and it's just a true or false value. So basically, for the end stop switch, it was set as true, I think, and so I had to set it to false, so that I basically just switched it from normally open to normally closed that way. And then once I've done that, then it would know that whenever these touch, or there's a contact a tool, and then this on the plate, they would connect the circuit. Once that was done, it would know that's Z, but the trick is that this plate, and this is again just like some scrap. I'm gonna make something nice that sits on there and finds the corner and all of that. But this plate has a thickness, right? So when the tool touches the top of that plate, it's still 1.5 millimeters off the top of the actual workpiece. So that's what that G92 command was. It took me a while. I was trying to go through like a probe command or like M281 or like a bunch of stuff. None of that worked. And turns out that the best way to do that, and I guess I can show you again if you're still interested, the best way to do that was a super simple, let's pull it up, Gcode, that G92 right there. Basically, that's just an offset. So what you need to do is home all axes, and then after you've homed the axes, you tell it a G92 command, and you give it, it's essentially an offset. You can offset in X, Y, or Z, but obviously I want to just offset my Z. So 1.5 is the positive 1.5 is the thickness. So then it just sets, it recognizes that as, okay, so instead of zeroing on that plate, it's zeroed, but it moves the datum down 1.5. So it says, okay, I'm at 1.5, which is at the top of the plate. So that puts the 0, 0, 0 datum on the top of the work surface. So yeah. Anyways, but yeah, I'm gonna keep playing with this, and I don't know. I understand this is like a really, really sloppy setup. Like it's cantilevered. It's fairly rigid. It's honestly surprisingly rigid. So it's doing a lot better than I thought. I am not out of the woods yet because this is just foam, even though it was cutting that pretty well. I understand when I move to like G10, it's going to be more difficult. And you can see here, there is like some play. And that anytime that you have play in your gantry or your tool or anything for a CNC, that's bad news. It's not good. So we're going to keep testing this out, and I'll definitely be doing updates. But yeah, I just thought this is pretty wild to take a flipping Ender 2, print some nylon mounts, clamp a Dremel to it, and then be able to cut stuff out like a CNC mill. Anyways, that's pretty cool. So yeah, another quick update. My Fat Sharks are all apart. Basically, let's see here, where is that chip? This guy. This is the power jack. This power jack has a little transistor. So when you plug in, this is the head tracking bay. When you pop that panel off, like you can put on your head tracking panel. Anyways, I accidentally popped off a transistor, and then this entire board just stopped working. So I've contacted Fat Shark, and they actually said, yeah, on the older version of these goggles, they recognize that people are popping these off, and they're gonna, I don't know if they're gonna send me another board or a replacement part, but they said they're gonna get me in contact with someone who can help me figure that out. So that's awesome. I was honestly surprised Fat Shark was gonna be able to do anything or help me out with that. So I'm pumped to get those back together because that's been driving me nuts. But yeah, I haven't been able to fly, so I've been focusing on other projects. Anyways, I want to, so this guy is pretty much done. There's nothing else I can do to this or modify this piece. So if you're interested in that, I'll throw that up on My Mini Factory. But then this guy, I want to do some type of vacuum to pull all this debris out. So I'm thinking I might introduce or modify this a little bit more to create some type of big shroud that you can put a vacuum hose or something into, and it'll start vacuuming up. I don't know. So I'm gonna try to put these files up pretty soon, and then just stay tuned for more of this crazy Ender 2 CNC conversion. Hopefully it works. Hopefully I can get this G10. That's what I'm trying to do, but we shall see. All right, are there any questions? Any other comments? Let's see here. Is there anything? Let's see. I think that might be it. I think that's it. All right, guys. Well, thanks for tuning in. I hope you all enjoyed that. If y'all have any other questions, just leave them down in the comments below, and I'll be sure to get back at you. I spend a lot of time fighting this firmware, but honestly, it's super easy getting it set up to go from printing. Oh, the last thing, dadgum, I didn't mention this. Another thing that I had to do was that normally a 3D printer, it's additive, right? So it goes to the lowest portion, puts down your base layer, and then from there prints and prints up. Well, this goes to the highest point and then cuts down. So with a 3D printer, there are some safety protocols set so that whenever you set 0, the hot end or the tip or the whatever you zeroed to never goes below that. And so I was having issues where it would run the G-code for the CNC, but it would only stay at layer the highest point. It would never cut down. And there's some stuff that I had to turn off in Marlin to allow it to feed down, because it was giving it like a G1 negative Z, and when you're 3D printing, like it just basically says, yeah, you can't do that. So anyways, all right, that does it for now. Hope y'all enjoyed it, and I will see you guys next time.